All right, everybody, welcome to the Ethereum Guild, third one of the year. Today we have Hasu and Data Always joining us as well. So thanks for coming, and feel free, I guess, whoever wants to start first, just to give the team a quick introduction. Yeah, welcome.
I go by Data Always. I do protocol research at Flashbots, mostly looking at MEV stuff, but also just like random places where MEV interacts with sort of the core protocol. So,
hi, I'm Hasu. I'm one of the stewards at Flashbots, so executive team, and I'm responsible for the strategy side of things, a lot of public-facing stuff. Yeah, assisting like the product team, fundraising, narrative, all that kind of stuff. And yeah, I also work as an advisor with Lido. So yeah, I think I can maybe provide a bit of a dual perspective when it comes to some of these topics.
Beautiful. All right, thanks everyone, and yeah, I'm Phil. Nice to meet you guys. And yeah, we have mostly part of the Lodestar team here, alongside with other internal people here at ChainSafe. So thanks for coming along and helping us discover this journey of what's going on outside of just our lens at Lodestar and the Ethereum protocol, and perhaps giving us a lot of information about what's happening around us as well. So why don't we start today? Let's start today with ePBS, because that's probably going to come up as a discussion point for when we do Amsterdam scoping. And there is a lot of complexity and a lot of different opinions here about ePBS, what it's trying to solve, the risks that come with it, and I guess at the end of the day, its impact, if any, on MEV. So whoever has, I guess, questions, I'm sure Data Always and Hasu could hopefully provide some answers for us here in regards to whether or not it's something we should continue advocating for, which is a challenge for us.
I guess for us it's contentious because we have these two things, like either we give up MEV to the builders, right, or like the alternative solution we discussed a lot last year is have something in protocol to like we did a proposal for deterministic ordering, which was an extension of Fossil. I think it's similar to Braid, which came out around the same time. So I guess that's the main contention we have with ePBS, because that basically means we give up on all of these solutions and just hand it over to the builder network, or hope that it works out on that end, and give it up on the protocol side, I guess, to solve it, at least in the midterm.
So do either of you guys feel strongly or have a strong opinion about ePBS?
Okay, sure.
I think
go ahead. Go ahead.
I mean, I think for me, and you guys articulated it kind of well, but like the question, like, what exactly is the goal? The sort of like old reasoning for ePBS used to be just to remove relays. And I mean, there's a lot of reasons why we, everything from sort of like the censorship aspect to some of the like relay timing games and monetization that they're doing. But if it's simply to remove relays, like there are other options, right? I mean, like Flash TE boost, we can move in that direction instead. Whereas if in these days, ensuring like a trustless payment flow, then all of a sudden, like ePBS becomes much more important.
So I apologize. Did the mic cut out for anybody else?
Yeah, I think there's maybe a small connection issue from you, Data Always. We got portions of what you said.
Maybe while he restarts or rejoins the call, I can speak a bit about my perspective. So, yeah, in general, I think the current ePBS proposal has this dual purpose, right? Number one, getting rid of the relay. Number two, delayed execution. I think the second one is like straightforwardly is a very good change. It's very helpful to increase Ethereum's execution budget. Like it brings us, or like makes it easier to get to like faster finality, like speed up block time, like has many benefits, I think. So it's like straightforwardly a good thing. Getting rid of the relay is, a lot of people are very like divided on it. So many MEV researchers, like both in Flashbots and in the EF, are quite nervous about enshrining any PBS solution at this point in time, because it's changing very rapidly, like the market structure that is. And so there's you run a very high risk, frankly, of like enshrining something that's suboptimal. We have just seen something come up in pre-confirmations and based rollups that is actually incompatible with ePBS, like as it's kind of theorized right now. So like, you could like imagine you like enshrine this this relay in the protocol now, but then it turns out, oh, we want a relay to play this extra role of being a gateway and like ordering transactions. So not, all of a sudden the current design doesn't work anymore. Like you could see many more things like that. So I'm quite against it on that basis, I would say. Also, I think from what we've seen, the out of protocol solution works fine. Like there's no, like it generally works for the validators, it works for the builders. Like everyone's largely happy, I would say. So I think that the final point would be that we have actually seen some other designs come up recently that can remove the dependency on the relay and allow validators to connect to builders directly and source blocks from them. So Paradigm released a post on this last year. We are picking that up. It's based on a design that we actually ideated internally, where one of the roles that the relay plays is ensuring the validator that the block is actually valid, right? And then it pays a certain amount. And so when you have block builders in TE, then the TE can give you that guarantee instead. So you no longer need a third party to verify it. So there are some designs around that we're actually pursuing. So, which is another sign that like the out of protocol market is still evolving quite rapidly. So I would say my bottom line is I wouldn't support ePBS today. Rather, I would kind of strip out the part that's really good about it, which is delayed execution. I think there's now 2 EIPs that are kind of proposing to do that in a more isolated and clean way. And yeah, just do that instead, I think.
You said something to me that was curious, or you said something that I thought was very curious. And this is the idea of relying on out of protocol solutions to do critical protocol work, meaning the selection and ordering of transactions. And this is something that I think we've taken for like it is a given. And it's something that I don't necessarily agree with, but this is one of those things that I'd love to hear your guys' thoughts on. Is it like, are the builders inevitable? Or should really, as an L1, should we be less focused on the like we should be pushing this MEV problem up the stack to the application layer to solve it, kind of like ENS solved it, or CalSwap solves it, or Unichain solves it. Do you know what I'm saying?
Yeah, absolutely. I think this is a really interesting question. I think there's kind of two general points here that are both important. So I think the first is kind of a general understanding of like, why did the system develop in the way that it did? And so like protocol external block building developed because block building was this really high value adding activity that was really like centralizing on the validator, very skill based, where the researchers and like the EF was very concerned that because MEV exists, that like some validators would earn much higher rewards than others and would lead to centralization at the protocol layer, correct? So that's why we basically...
So they came up with a solution that literally centralized it even further.
Well, it introduces this intermediary market, right? Which is MEV Boost or out of protocol PBS, where any validator, actually, no matter their size and their sophistication and their geolocation, can source the same quality of a block to build. So I think, if you follow that design logic, then that is a big success, that the validator is actually kept much more decentralized than I think than it otherwise would be. So now I think a logical response or like follow-on, like skeptical question to that would be, well, what did we actually gain by keeping the validator decentralized when they are not actually used in building any of the blocks, correct? So I think this is an excellent question. And so I think that the validator should actually be more involved in building the block. So I'm personally I'm a proponent of a dual solution here, where like the more sophisticated version of the block building is handled by block builders, like by this external market. And then the block builder can provide, something like, I think we've seen the idea of like an includer list, something that's being added to the block. I think this is, in my view, like a really good idea. So this way you can actually tap into the very decentralized validator set in order to increase the censorship resistance of the block, but without putting a lot of like any hard requirements on the validators, which they are actually, I think, unable to fill. So I'll pause here, kind of second point, but want to make sure if you agree or disagree or.
No, that's like FOSL is, and I know that most of us on the team really do advocate for FOSL. I think it's a great idea. But it feels like the dark pools are almost as big of an issue as just what gets selected for the block, because you now have this incentive for companies like MetaMask or large wallet providers to be or sexes to be pushing transactions directly to the builders in these dark pools, which is further entrenching the builder and almost, if you carry it to its final inevitability, that there will be very little in the mempool anyway in order for validators in order to pack the inclusion lists.
I think you can look at it also from the other side. These wallets and apps are not sending it to the private mempools because they need to in order to get it to the builder. Builder can still pick it up from the public mempool just as well. Mm-hmm. They are doing it because it's much better for the users, and they are all like, there's competitive pressure to improve user outcomes that actually drives them to use private mempools because they are giving users like much better outcomes, right? They are more private, so there's no sandwich attacks. There's typically an order flow auction involved somewhere in that stack. So users who inadvertently create any MEV, they usually have that MEV recaptured for them. So I think the current system works actually, from the user perspective, it works really well. I think the more interesting question is like, okay, what is the systemic outcome for Ethereum? And like, what are we concerned about here?
Like, there is this unique monopoly that before the builders, the proposer has on selecting and ordering transactions. And that is because it's so valuable for the same reasons that our traditional financial system focuses on order flow. And it's how Schwab came to be and Robinhood came to be. To me, the fact that it puts this power into organizations' hands that is by nature, they are very opaque. There is really no clarity into how sandwiching is prevented. They say they do, and they say they do order auctions, but how do we know that they're not, it's just trust us? Is there a better way in order to, bring that in protocol, do you think?
Yeah, so we have you read about BuilderNet?
No.
Okay, yeah, so this is a decentralized block building platform that we're working on at Flashbots, and it is basically putting the block builder, it is putting the block builders in a TE, and those TEs both keep the user transactions private in a credible way, and they also attest to running a very specific source code that you can look up on GitHub.
Mm-hmm.
Anybody can verify that the block builder is exactly running that ordering algorithm. So for now, you can actually get an attestation that you are exactly executed in a particular way. So I think we're doing that because we believe that is the natural kind of endpoint for this market, right? Like we can get into the pros and cons of TEs.
What is a TE?
So it's a trusted execution environment.
Oh, okay. Yeah.
Like Intel SGX, Intel TDX. There's some more. We are on Intel TDX. So it's a hardware design that basically like uses secure enclaves to run. It's private box where you can put code into, and it's run even like out of control for the hardware operator itself. And it gives you data privacy and like integrity of the software that runs inside. So it has two downsides. It requires, it's still a relatively young technology, so it requires trust in the hardware manufacturer, because you're outsourcing that trust to them. In this case, Intel, that they haven't put some kind of backdoor in, because they actually need to like authenticate every individual machine. And say that's the exact machine that we have built. And then the second one is, in previous generations of TEs, there have been kind of break-ins into them when like highly sophisticated, well-resourced actors have like physical custody of the machine and can like take it apart under like photon microscopes, and like, so you need like a lot of equipment to do it. But so we're using it in a way that like is aware of all of these like shortcomings. So you only like the builders run in like data centers that like where the operator doesn't have custody of the machine itself, and the data center tests to like using a proof of data center that it's actually running there. And so yeah, we can get more into that, but like just think of it as like this magical server where you can, even the server operator can't look into what's running inside the server, can't look at any of the data, and the server is like a blockchain in that sense. Like you can
I understand. Yeah. And do you have a trusted methodology for how? Oh, sorry. Go ahead, Peter.
Yeah, I just wanted to, since we are on the topic, I wanted to just maybe ask a couple of questions, because at some point I was following the Intel SGX, but I also realized that they kind of retired SGX about on 18th or 12th generation. Did they introduce something new? Or
so I don't think it's retired. I think it's the they used to have like a consumer version of this and the enterprise version of this, and the consumer version is retired. So that said, like we're using Intel TDX, which is, so I'm not exactly the right person from our team to ask about this, but the difference I think between Intel SGX and Intel TDX is that in SGX you are basically like you're running, this is like a virtual computer that's like running on some, how to explain this? But in Intel TDX, like the operating system itself is basically almost like baked into the hardware itself. So it's like
Mhm.
it's part of the whole. It's part of this system that you're proving. So you're proving like the entire operating system. So it's more virtualized in that sense.
Yeah. Okay. Okay. Thank you. And second question is like, have you checked? Yeah. Are there any solutions from AMD that you know of? And do you know if maybe like around RISC-V there is something about TE that is being built?
Yeah. So AMD has its own version of the TE, but it's generally less performant and kind of less mature, especially in terms of the proving infrastructure. So the way that like these attestations work, it's not, we are working with a lot of people in the supply chain, like the general like software, hardware, and data center supply chain, to kind of get these things to where we feel comfortable about using them for Ethereum. So we're taking a very proactive approach, kind of steering the overall like supply chain where we want it to be. But yeah, the like AMD's version is not in the place where we feel like comfortable using it yet. But like longer term, I mean, I would envision that you can basically design like meta protocols in the sense we're using not one TE from one manufacturer and like one data center, using actually several TEs from several manufacturers in several data centers, and like they all need to agree, right? So I think that's a way you can, you know, really get around some of these like trust issues.
Like an abstraction layer on top.
Yeah, exactly. Yeah.
Also,
Okay.
I think
Okay,
right,
thank you.
the argument why TEs are okay here is because you only need short-term integrity, right? It's not like you have secrets that are worth exposing. Because it's quite interesting. We did the trusted computing, we called it back then, in 2019, where it was pretty immature.
Yeah.
I think you even worked from Intel, a colleague worked with Flashbots, or worked with you. I'm not sure with whom exactly, but yeah, it's interesting evolution. But I guess I still see it as a midterm maybe solution. We internally also talked about like pure software homomorphic encryption, like for the long term, to have it purely on the software layer and not rely on hardware. But I guess, yeah, I mean, the performance there's too far off to produce blocks with that. But I guess
all of what you said is basically spot on. Like, so, you know, TEs, like the biggest risk, you know, of a break-in is when you store like long-term secrets, which we're not doing, right? So the block builder generally today is like a stateless machine in the sense where, you know, it's like every round it's like starting fresh with like no memory. So there's no long-term secrets stored except like the financial value of those in-flight transactions that it's processing. So you're only trusting it with that. So like, you know, if it gets broken into, the risk is actually like, it's quite low. And then longer term, so Flashbots is doing a fair bit of research into cryptography-based like private computation solutions like FHE and MPC and so on. And yeah, so like generally, I think we're quite far away from being able to use those for like to replace the thing that only TEs can do today. Because I mean, the biggest problem is the latency. Like block building needs to be done at really low latency, and you know, with any type of multi-party computation, even if you assume already that the cost of computation is completely free, then you still have this, you know, problem between how many rounds of communication you need between the participants, and like how robust, you know, the mechanism to be, like how much fault tolerance should it be, and whatnot. So like we are, I think, quite far away from being able to run like something as big as a block building algorithm inside. So that said, it can be used for defense in depth, and I think, you know, we are thinking about that, for example. So you know, yeah, like you can, for example, when you use both TEs and multi-party computation, then what you get is you reduce actually all the like protocol participants' ability to like create faults in the mechanism, which then allows you to reduce the rounds of communication used, which then lowers the latency. So there's like an interesting feedback loop there, and I think maybe in a couple of years it is viable. But yeah, like the end game is I think for all of these techniques to be used in conjunction with each other, providing defense in depth.
This is a really interesting segue, and about the end game, because this is a really interesting idea and the first I've heard of it, and I think it's excellent. But there are these fully entrenched players that are the 800-pound gorillas in the room right now, and they are building 98% of the blocks or whatever the number is. Well, do you guys, like, assuming that the technology is perfect and these TEs work and everything is ideal and all the nuances are hammered out, what is the roadmap in order to gain market share back from the builders? Is it something that you would expect the protocol to kind of enforce, or do you see it as rolling it out to them, or what? How does it actually like turn into a real solution?
Yeah, it's so we have released BuilderNet late last year, and for the first couple months we were purely focused on going into a place where it is actually performant enough that it can reach parity with the best centralized block builders, because we don't want to like basically pour water into a leaky bucket. But now we feel like we are actually we have reached parity with the best centralized block builders, and it was this took us many iterations to actually arrive at a like TE design where you can run the same software inside and like get the performance of a centralized bare metal server. I think we are down to less than 5% performance overhead compared to like the best centralized version you can do. And so we announced, I don't know, 1 to 2 weeks ago that Beaver Build, who is the largest centralized block builder, is integrating in BuilderNet by end of the year, and like they're joining BuilderNet as a core developer, and they're also transitioning all of their existing clients over. So we actually feel very confident that we are at a tipping point where now I think it will be more profitable to build blocks inside BuilderNet than do it outside. And so,
is the idea that the participants get like a share of all the MEV that comes out of all of these blocks that get built, or what is the economic incentive for them to do that?
So it's a nuanced answer to this. So in the long term, the idea is to actually have competition on block building inside BuilderNet, as we unbundle the block builder and make it more modular, but do it in TEs on top of order flow that is private, but that everybody can access. So that's the long-term vision. So you can have like an MEV supply chain that works, a little bit like today, but it's all actually inside an encrypted programmable mempool. In the short term, if you join BuilderNet as a pure operator, then you're running the same code as everybody else. So there's no internal competition. You're not competing also with anybody else. So because if you did, then if you had the same order flow and would compete with yourself, you would just bid away the value of the order flow to the validator. So it's more of a kind of like it's a block building platform, but where like it acts as one monolithic builder that is internally decentralized and has multiple operators.
You said something that perked my attention, is that you would be like, I thought the whole idea of having multiple builders is that it ends up returning more value to the validator set because the bidding tends to give as much value back to the protocol as possible. Can you speak more to that?
Yeah, so that's exactly correct, right? So, MEV Boost was designed to maximize basically payment to the validator, at the expense of the user, you could say, right? So it's like it basically ensures that all validators can source the maximally valuable block. So I think BuilderNet is more a product that is aimed at like hardening the supply chain itself and making sure that like the block building process is as decentralized as it can be. So BuilderNet itself, might still compete with other builders who are not in BuilderNet, or it might have it might just programmatically bid a certain amount to validators, even if it was outside of the competition. But it is designed to basically maximally return MEV to users. So it has a specific feature that sets it apart from other builders right now, which we call refunds, order flow refunds. So if your transaction creates any MEV or pays any excess transaction fee, then you can be refunded that money because you're basically contributing to the surplus of the block. And when BuilderNet generates any surplus against other builders, then basically anybody who contributed to that surplus, they can get a refund. And so this is to understand why that's important.
You get sandwiched. The builder ends up extracting that value, recognizes that the value was extracted, and refunds you.
Yes, exactly. And so
yeah, but the person who did the transaction that sandwiched is the one who gets that value, not the builder. Where's the money come from?
Can't you like ensure with BuilderNet that you cannot sandwich like in the code?
Oh yeah,
It's provable, right?
Yeah, exactly. So our builder doesn't, it treats all the transactions as private that it receives and does not expose them to any, runs any internal searching on them. So that is all verifiable.
I think the MEV is rather like friendly MEV, like background ink, for example, right?
Yeah, so imagine the easiest example is maybe, well, there's two types, right? So you can pay too much in priority fees. And then if you pay too much, then you can be refunded the difference between what you paid and what's actually needed to be included in the block. And so, with MEV, it works similar because, maybe your transaction can be backrun and then it would be backrun and then that value can be returned. And it's actually, you can think of like overpayment and priority fees, and MEV that's created is both a form of like implicit transaction fee that you're paying, right? So the whole idea is instead of like paying in advance or deciding how much you pay in advance, or you pay a transaction fee, but you also create any MEV and you're not really factoring that in, the system is just implicitly looking at all of your payments as like one fee, and whatever, like only the minimum that's necessary to actually get included in the block is what you actually pay, and then you are refunded the rest. So it's, even if you think about auction theory, it kind of works as a second price auction in that sense, where you only pay the cost of like replacing the next highest bidder.
Yeah.
Okay, so so it's pretty good from the user point of view, but how do you actually outbid a centralized builder in that case? Or is the assumption, okay, we provide better UX, so more order flow means more bid value in the end?
Yeah, exactly as you say, right? So you need to make a more valuable block by attracting more order flow that cares about the features that you provide and the architecture of the system and such. So that's why for us it's a big endorsement that the largest block builder said that running a block builder for us is more of a hassle than like anything. And like we make most of our money from searching actually, so we would rather join BuilderNet and like outsource the block building there and contribute to that, and like focus on searching instead. So that is because that's a big endorsement, because it is one of the most demanding types of order flow, right? So if you're kind of an HFT trader and you're saying I can use BuilderNet, like it works for my order flow, and I'm trusting it, that's very good, because like that order flow is very demanding in terms of execution speed and such.
Yeah,
You
I
know,
mean, today we really have like a lot of siloed order flow between different block builders, and part of the advantage of this with the permissionless order flow sharing, right, is that all of a sudden you can bring together all these siloed sources of order flow, and you can end up returning more value to the validator, even though users are getting better experience.
Do you see Titan also coming over to this way of thinking?
We are trying to convince them. So,
Mhm.
yeah, I think it's an ongoing, ongoing discussion.
So if all builders join it, basically you only have a single bid that comes out of BuilderNet, or how does that work from an auction point of view?
Yeah, correct. So if all the builders were to join it, or enough builders were to join it that it's out of competition, then yeah,
I mean, yeah, in theory you would push out all the other builders anyway, right? If the theory holds that you attract the most order flow, so yeah.
Yeah, so I think that would be a possible outcome. Yeah. So then in that case, so BuilderNet would basically have a programmatic rule of like dividing the value of the block in a certain way, right? So it would not push the rewards to 0 for validators. And
This
like
was my question. Like, this is
Yeah.
the question that I had before. Like, is if there's going to be no other competition, and you're preventing competition within BuilderNet, what's stopping BuilderNet from doing, exerting monopoly power?
Yeah, I mean, ultimately the validators connect to BuilderNet because they want to, right? So because they think it's giving them the best block. And if they no longer think, it's giving them the best block, it's bad for the validator and it's bad for BuilderNet and it's bad for Ethereum. So, I think that it will just have a programmatic rule of like bidding a certain amount, and that rule can be, maybe tweaked slightly over time. But like in general, it must BuilderNet is facilitating a market between the validator who sells the block space and the users who consume the block space. And both sides of the market must be happy for the system to work long term. So.
And does BuilderNet have financial, is there do you guys take a VIG or a rake on whatever it is in order to make that connection and to build the software?
Yeah, so the plan is to charge a service fee. So for like the order flow that's going through the system. So don't know how high that will be. It's a little hard to tell right now because the system is still very small in adoption and immature. So you need to make it sustainable. If it's some protocol infrastructure, so it must make money to not only finance it, like its operation, but also its improvement over time, because we have pretty ambitious plans for it, and like we also want to connect the layer 2s to it, for example, as well. So we are seeing blocks now for some layer 2s, but the idea is that BuilderNet is really this. We're building this into this like extremely decentralized, extremely private auction system for conflict resolution, and it's starting on Ethereum layer 1, but like it should ultimately
be for all of
system.
Exactly, all block plays could probably go through this thing.
Yeah, exactly. And then it becomes much more of an easy decision. Should I outsource actually my block building? Well, because you have a way of doing it that is actually like it's good for your users, it's decentralized, it's private, but it's also like revenue maximizing for you, and it may facilitate interoperability between the different chains who are connected to it also. So I think that's the more long-term vision.
Now, how does this support like the L1, and why not just roll this idea into the L1? And like, why make the case why the L1 should give away this value and not try to, or you guys should not donate it back to the L1 or whatever I don't know the right word for it. You know what I'm saying? But like, why not make it public goods, should I say?
Well, okay. It's a good question. So, I mean, first of all, I think that Flashbots, the company that is now 5 years old, is built around the idea of decentralizing block building and kind of making that more decentralized and private. I think if you have a highly specialized company with like that as its mission, it is pretty hard to do it like more efficiently, more cheaply. It's already kind of the best form factor, I think, for what we are trying to achieve. So you can try to do the same thing, let's say in the client teams of the Ethereum Foundation, but I think you need, you just need it's very cross, how do you say it? Like touches many different fields of knowledge and engineering to kind of develop this, and requires a lot of vision. And so, I mean, I think honestly, it's very hard for anyone else to build this. Even we are only figuring it out over time. And that's one argument. I think that being for profit and being a public good is not at conflict at all, actually, with each other. So especially if you're making a decentralized system, the decentralized system can have like a certain basically take rate programmed into it, and then the participants need to agree to change that take rate. In my mind, a lot of I mean, one of the good things about decentralized networks is I think they can just scale much more than the centralized ones could, because they require less trust to adopt. So if somebody builds or uses this for their chain, then they need to rely, in 10 years, this thing is not only continuously improved as the tech matures and I'm capturing all of these advances for myself, but also, it's still around in 10 years and 20 years, right? So I have no substitute for, if you want to play in the MEV market, build a system like that you want to do it in this for-profit way that we're doing. And then the final argument off the top of my head would be, you may want this system to be neutral. And I know it sounds kind of weird, but even more
neutral than L1.
yeah, exactly. I expect this was when I heard it, myself say it, I was also laughing. But I think that at the limit, this can connect more chains than even just the Ethereum ecosystem. So I think that it's not crazy to me to think that, well, it's building blocks for Ethereum, but also building blocks for Solana and for whatever chains may exist, and for centralized exchanges and so on, right? And I think you want to have a path that is not a chain itself, is some other system that's more acting as a connective tissue. But yeah, it's getting relatively speculative there.
Yeah, I mean, especially considering all the discussion about base rollups and sequencing going back to the L1, and so really it will all be one thing in the future anyway, if that future comes to pass. I know that's a big if, but it will all be sequenced in one place anyway.
Yeah. So it's interesting that you asked this. So there's a lot to be said on base rollups, but let's assume that it's actually happening that way. So all of the layer 2s will opt into being sequenced by the layer 1. So in this case, I mean, you need a few things to get this interoperability benefit, right? You need a shared proposer. You need a shared block builder, because just the proposer itself is not enough. You need to build blocks that are actually cross-chain aware. And then you need this, real-time proving, of course. So let's say we have all of that. Then BuilderNet is basically playing this role of the shared block builder, right? So it's still extremely useful in that world. And I would say, in fact, it's the only way that the based rollup vision can be realized without massively centralizing Ethereum. Because how else do you want to build, cross-chain aware blocks if you can't figure out a way to do the block building in a decentralized way? You'll just end up with one ginormous builder in one data center somewhere. And I mean, then you have a really, really big bottleneck on your hand. So I think this this is actually the like a really essential part of this more like cross-chain interoperability vision, whether we have based rollups or not, but especially in the based rollup case.
You know, and the from an ethos perspective, and I think this is and something that we've talked about a lot is like the idea of the builders are antithetical to the ethos of why we all joined the blockchain space, you know, to build a better future that is more egalitarian and more meritocratic. And it sounds like this is something that you guys are working towards, but what are the guarantees? Is it just because it's open source and just because it's audited and that makes this builder net superior?
I mean, I think it should be architecturally decentralized. That is the baseline, right? So it should, you know, have many operators, should be permissionless to join. You are not trusting any one particular data center or hardware manufacturer optimally, like people can run it on their own premise. So yeah, I mean, I think that is really important. That is the goal, right? So and if you have that, then you can get the benefits of block bidding, which is, I mean, block bidding has this like very inherent, it has this one inherent benefit and this one side effect. And the inherent benefit is, you know, there is actually like virtue in the fact that you have these many different preferences of users who all want to touch the same state to resolve this state conflict in the best possible way, meaning like as many users as possible can actually transact at the lowest possible price, and at the same time whoever sells that block space, you know, can make the most possible money from it. Like that is important. That's an important efficiency goal in itself. And designing the best possible auction, in the sense, my preference is private until it's included. I pay the minimum amount of money for my inclusion. I can express the broadest possible range of preferences about how I want my transaction to be interpreted, what I want it to do. That is all really, that makes Ethereum straight up a lot better. I think if you look at, you know, one of the things where Ethereum is most leading in terms, like compared to Solana, for example, or any other chain, it's like how much better the MEV supply chain is, like how much better, frankly, the experience is when you transact. Your transaction never fails. It's private. You know, if you have any MEV, it's captured for you. Also, the maturity of the app ecosystem in terms of MEV is much more mature. But this like side benefit is you are preventing these negative externalities on the chain itself, right? So you basically prevent the centralization from MEV to spill over on the validator, and you can also prevent other forms of negative externality, for example, in the form of spam, which we have also seen at different times in Ethereum. So if you run an inefficient MEV auction, then you basically get spam as the dominant extraction format. So I did want to revisit a question that I think it was you, Matthew, you posted earlier, right? Which is like, should we solve MEV at the protocol layer, or should we push it back up to the application layer? Yeah. So the view that we generally hold, and which is aligned with what I was saying just now, is you want to do both, and they are not mutually exclusive at all. So you always want to minimize the MEV at the order flow layer, which includes, you know, the user, the wallet, the application, and the way that and you want to maximize it then at the protocol layer. And this is the best way of doing it, because so if you're a user, you know, you control your own transaction, right? So you can control where you send it, what app you use, how much information you reveal, and you have that full control. So nobody is like has more capability of like programming that transaction, making it private than you. And you are also highly incentivized because you want to pay the minimum. So I think you're seeing like at the wallet layer, you see all of this adoption of private mempools and order flow auctions and smart transactions and whatnot. At the app layer, you see really intelligent designs like CowSwap that minimize MEV. They are all, already highly self-interested to push this. And MEV has gone down so much from a couple of years ago, Now the execution layer rewards are, I think it's like 0.1 or 0.2% of the overall APR that validators are earning. It's almost all attestations now because, we've done such a good job of like the apps and the wallet and everyone together has done such a good job of basically, preventing the creation of this MEV in the first place. But then when it actually arrives at the validator or at the builder, then it is very important to maximize what's left because you don't want to get into a situation where some validators can make more money than others from becoming more sophisticated, building out their own switching operations and whatnot. So, and that's exactly, I think, the paradigm that, that we're in, fortunately, but also that I think is optimal, which is minimize MEV at the order flow side, maximize it at the validator side. And I think if you do both of these, then yeah, you end up with like the most user serving, but also like the most robust possible outcome.
And do you see APS, if that does come to fruition, changing your viewpoint on that?
What do you think, Data?
I think the current designs around APS are not all that strong. So it's probably a question I haven't considered that much. There's not a lot of research about how centralizing APS is. You might just end up with something like BuilderNet emerging from it anyway.
This is what I'm wondering. Yeah.
Yeah. Also, there was one point you brought up, Hasu, was that the validator can just select another builder, right? But this doesn't exist with APS. And you do not have like local fallback, which I don't like either.
Yeah, I think we haven't seen all that many APS designs. So you're right that if there is APS, there's no fallback to local building. But you could have basically almost like an open source community run builder, even in an APS world that provides set some kind of floor price in the auction, right? I think that's possible even in that world. Other than that, I don't expect to change anything.
It almost sounds like you wouldn't even, if this BuilderNet does really take off, because it does seem like, I'm not going to lie, I am a big hater. Everybody here can tell you I hate MEV, I hate builders. I do. But this seems like actually a really good solution. And it's something that I am excited to hear about because I think a lot of the people I've spoken to in the core dev community are a little frustrated because it's such a difficult problem to solve. And I think this is a very interesting novel solution by using, by expanding to the hardware layer. It's very interesting, but it does kind of lend itself to that idea of like APS because you have these specialized builders and you have this, a lot of this work gets offshored out of protocol, and it starts to lend credence to some of these other ideas that I think, as Nico mentioned, really they kind of kill that independence and that the ethos, like the fallback and the censorship resistance. And,
you also have like the local override, right? We have that already, that the EL can tell the CL that the builders are censoring. You kind of lose that as well, I think. So, we would need something like Fossil maybe, but yeah.
The main strength of APS is just that you have these sophisticated entities. And because you assume them to be sophisticated, you can just slash them if they misbehave. But if you can get similar guarantees from TEs, does it really make sense to make such a large change to the protocol with APS? That comes with so many uncertainties.
So what do you think is the main argument for APS versus keeping as is or ePBS?
I mean, when all of the APS proposals were created, there was no BuilderNet. And I mean, if BuilderNet catches on in the next couple of years, like, I don't think that APS will happen because it's just too large of a change for what it is.
Yeah, because the only thing I read was that it prevents co-location a bit because you don't rely on latency between validators and builders.
I mean, I think APS is a kind of logical end state. Just, I mean, if you play out this market like enough times, you end up with something like this because it's, you know, it acknowledges that, you know, the builder already has much more power in the MEV supply chain than the validator. The validator is only doing this like quote unquote rubber stamp on the block that the builders built. And so, you know, if you have that anyway, you know, I think a version of APS where it just dramatically simplifies how the protocol works could be very beneficial then if it like leads to more scalability, right? So if instead, like if you only have the build, like if the builder and the proposer are actually the same one and it's just all done on demand, and then you have the testers on top of that, and they also constrain that builder through something like fossil, you know, includer lists and stuff. I think something like that is generally a good direction, as is like the general like unbundling of roles in the protocol. You know, no longer all done by one party, but you have like bigger nodes and you have smaller nodes, and like the smaller nodes keep the bigger nodes in check, and like they check each other's work. I think something like that is probably like an important building block in how we scale Ethereum. But I mean, I'm not strongly held if it needs to happen or anything. I think it's more of, it's elegant, and you know, we are moving somewhere in that general direction, I think, whether we want it or not.
Yeah, I think directionally it's definitely the case. I guess for me, it's more like I'm opposed to this from a philosophical point of view, that you cannot build yourself.
Yeah.
Because that's what made me interested in Ethereum, again, in proof of stake. But yeah, I guess we are heading towards that path.
I guess the question that I would have for you guys is, with the current like L1 scaling roadmap, like how far do you think that we can scale local builders and still keep good liveness rates, right? Like right now, reorg rates for local builders are like 0.7%, but that's really artificially low from the reduced gas usage with everything going through private mempools. So if you look at sort of like the rate at 30 million, you see close to like a 5% fork rate for local builders.
Yeah, I think it's also a bit artificial because most local blocks, they wait for min-bit. So you wait 1 second into the slot, usually, until the header timeout happens. So the local block is published really late compared to when it could be published.
I mean,
yeah,
does that make a case for shortening the timeout?
I mean, long term, I think you would need to cap the blobs and stuff like that, like the gas limit even.
I mean, just looking at what we're doing on PureDAS, I mean, some of those are running 12, 16 blobs and 45 million gas or whatever it is, and everything's running fine. And it's all local built blocks. Now, granted, it's a small network. It's a dev net, but you know, things run fine. You know, so will it scale further? I think with more performance focused mindset in order to do that just on the clients themselves, I think it's very possible. You know, is it going to run on a Raspberry Pi? Probably not. But we were actually having this discussion yesterday, is that, you know, is that realistic in order to think that you're going to do local block production on a Raspberry Pi? But most people who have enough money in order to run a validator, you know, 70 grand, 100 grand, whatever the number is, have a 6 or 8 core minimum box, and they have a decent internet connection. And it begs the question of, should the minimum requirements be something more reasonable to what, you know, $1,000 or $2,000 worth of hardware can buy?
I mean, it depends what you want the local blocks for, right? Is it like to be still competitive with builder blocks, which is already not the case, or do you want it as like a liveness / censorship fallback, basically?
Correct. that
Yes.
to me is what they're
Not sure what your guys' view is there, but yeah, like the long term.
Yeah, I mean, from a like keeping up with the builders perspective, it's that ship has sailed in my book. You know,
correct.
the biggest problem with, aside from like that, just the hardware requirements itself to run like a really performant block builder, I mean, is the trust requirement, right? So, like in this time, like people expect their transaction to be private, and they can't trust like millions of or even thousands of validators who they don't know, right? Like if you can't at the same time want it to be permissionless and open in that way, right? Like permissionless, but then also private. Like we haven't figured out how to do that. I think the equation changes maybe a little bit when you have all of the validators running in the TE, but I think as an Ethereum network, we don't want to, you know.
Yeah, but I think
for now.
like I think there's a fallacy in that statement is that everybody wants their transactions to be private because just because a lot of the transactions today are DEX transactions or sex arbitrage does not mean that that's going to be the utility going forward. Like I've built a lottery program on it. I've built an IDP in order to do IAM for access control on centralized servers. I've built, there's a lot of other use cases that have nothing to do with MEV, where it's not an interesting transaction, and all you need to do is just have it included on chain. Like, and I think as the industry matures and there's more and more of these logistics reportings and just stuff that is just like mundane run of the mill, not arbitrage and not MEV. I think more and more stuff doesn't need to be a private transaction or L2 transactions. Like they're rolling up. Like there's no, unless you're doing
I guess
sequencing.
the question we discussed previously was like long term, do we think that there will be a lot of MEV transactions even on layer 1 if we move it all up the stack basically? Like unit chain or similar, like
Exactly.
I mean, yeah, Matthew. I mean, I think you're right. That so there can be, it's not a given that like the share of like MEV of like transactions that need privacy will only ever increase. I think it could realistically also go down. This is ultimately hard to predict. Personally, I think that like blockchains are, they will find their first really good use case where they have the biggest comparative advantage in DeFi and like DeFi adjacent things. I think we're seeing now that this is where crypto like breaks into the mainstream and like sees the most adoption. I would expect that to continue probably for the next like 5 to 10 years at least. And then what happens after that, who knows? I think.
Like, and this is the thing that I think is the most important, and it gets lost in this whole discussion, is that like blockchains are a root of trust. Like blockchains, what they really do is create trust among the trustless in a decentralized way. Not that they are a way to manage money, not that they are a way in order to create bourses. Like if I want to know if my shipment is included on a container ship, and there's 3 or 4 different stakeholders that are involved in that logistics discussion, like blockchain is an ideal solution for that. Like there are so many other use cases that I think are really starting to come into fruition. Or another one, like, so I have a friend that works at the United Nations, excuse me, and they work with a number of governments that there are stakeholders that are deploying capital, and then there are stakeholders that are looking to invest that capital for humanitarian purposes. And then there are also suppliers and vendors that are absorbing that capital in order to help provide the value. And being able to provide transparency between the people who are donating the money, the people who are deploying the capital, the people who are managing these applications and these use cases, the vendors that are doing the bidding, like all of these use cases, which are things that are still in their infancy, are ideal use cases for blockchain that really haven't happened yet, but they're coming. or DeFi is another a great example, or intellectual property, or real estate transactions. Like Dubai just announced a $9 billion, or what, it's like a whole city within the city where all real estate management, all mechanics liens, all deed appurtenance, everything is all going to be managed on chain. And again, this is another exact example of like something that has nothing to do with DeFi, has nothing to do, there's no MEV there. There's no, these transactions don't need private order flow. Like I think there, well, I'm rambling now, but there is, like, I think that this is a great solution that you guys have built. And I think it frees up at least my burden as of thinking through L1, that there are so many other things that need to be built out. Like you're saying, can we scale with the hardware requirements that we have, or how do we handle scaling and synchronizing across L2s? Or like, there's a lot of other problems that can be solved that we just don't need the mental horsepower to think about ePBS. Or this to me, I think, is a great service that you guys have provided. It's really wonderful.
Well, thank you. And yeah, I mean, I agree with all of what you said. I think if we want to get to this future, I think a certain degree of like division of labor and like specialization, I think, is a very good thing, in the sense, for example, empowering like someone like you to think about scalability of the layer one, and like designing PDAs and whatnot. I think that is like, for me personally, if I think about, well, how can we free up like the client devs and the researchers to think about like the UX of Ethereum, the interoperability, the scalability, are like three big things that come to mind, right? And yeah, how can we give them some peace of mind about the MEV roadmap? I think that's like, if we can provide a little bit of that, I think that is that's a win for everyone.
Amazing. And this has been unbelievable. Might be the best Ethereum Guild talk we've had so far. I don't know if everybody else agrees. This has been awesome.
Yeah, this has been super useful because we don't get a lot of time to explore what's going on outside of protocol, but getting a better understanding of how the work you guys do affects us, and the other way around is like super useful.
Also,
so
finally, someone convinced Matt while I was trying this for years, or not years.
To not do in protocol transaction ordering.
I'm
Yeah,
scared, but I like it.
but yeah, so I mean, I guess it's nice if we can say, okay, we let the MEV problem, let it be solved outside of the protocol. But to me, it's like, I think we should still do at least something that helps, at least, like, even if it's just something that's a slight benefit for BuilderNet, or I mean, whether that's ePBS or, like, me personally, I'm more interested on working on that stuff than like the scaling stuff. So I guess what I'm saying is there's still protocol developers that care more about this stuff than scaling. So what do they work on, or what can we do?
What do you think, Data?
I mean, I think that fossil is probably like the strongest thing that we can do in the short term, right? I mean, I think at the very least it provides a lot of peace of mind to people, and even if it doesn't work that well for like MEV bearing transactions, sort of like putting a leash on builders a little bit would go a long way.
Yeah, one other thing. So I agree with that. One other thing that I'm thinking about. So we didn't get to touch on this today, but I'm actually pretty bearish on the idea of pre-confirmations. So I think they are very centralizing on the MEV supply chain. So if you're worried about builder centralization, then pre-comps certainly make this whole problem like much harder to solve. It's a little bit too hard to get into in the remaining time that we have. But I think if we can, like, the idea of based rollups is in itself a good one. It's just that like pre-comps are not really a great way to like speed up a protocol in a way that still lets it be decentralized. So I think to the degree that we can lower the block time of Ethereum, that is a way that we can still push towards that based rollup future without having to rely on this like centralized pre-confirmation gadget that's sitting on top of the protocol. So yeah, Nico, that seems to be also one thing that's like, I think everybody generally agrees would be good.
Yeah, I think that was also a question or point I had, like the impact of lower slot times. And I guess the whole delayed execution in regard to that. Without ePBS, I guess.
Mm-hmm. Yeah, I'm not the like perfect person to ask about this. I mean, there's some evidence in general that I think like lower block time is associated with lower MEV. I mean, almost exclusively because of decentralized exchanges where market makers can like, there's more ticks basically happening where like over the same two end states where the price can like move up or down, increasing the trading fee. That's kind of the intuition. And I mean, it's like better UX also for users. So it, might be just like good for Ethereum for that reason alone. And then it's good for like base rollups that want to use Ethereum layer one's MEV supply chain for their block construction. So I think you have across the board. I mean, it's for sure helpful. How much I don't know. It's probably not detrimental in any way.
There's one other question I have, part shill, but part because I think it'd be interesting to you guys. On a, it was a hackathon I did several years ago where I did IAM, but blockchain based. So I used on-chain, like a smart contract as the IDP. And then the client was, it was to manage an AWS account. So I just used the other side of the handshake in AWS. So you could basically log into AWS accounts. And it created CloudTrail and logging that basically locked down an account from anything other than the smart contract. And I'm curious, how are you guys managing the IAM of these secure servers? Like, how do you prevent, other than traditional IAM, which is susceptible to the people that are in the data center?
That is a great question. I'll hit you up after this call so we can like write it down and I'll get you the answer from our engineers. So sure. I know they are thinking about physical security and like access control, but I'm not myself deep enough in the topic to answer it off the top of my head.
Well, I've got a couple repos. If nothing else, you guys take a peek and if it sparks you guys ideas, it'd be very cool to help in any way we can. We
are super open to receiving outside contributions to BuilderNet. Like this is a project that started inside Flashbots, but the idea is for this to become basically its own decentralized network with several like contributors, like open contribution, several teams, a governance process, BuilderNet improvement proposals and whatnot. So, I mean, for sure, this is an area where we are very happy to get help.
That'd be great.
I mean, beyond that, like BuilderNet's been built with an ethos around open source. So, I mean, if you guys have more questions, and particularly sort of like technical questions, would really encourage you to hit up our forum, and I mean, you'll get responses from people.
Do we have contact information, Phil, or is there a way we could pass information back and forth to each other, or Discord or Telegram or something?
We could open up a Telegram group together. I don't think we have one yet.
Awesome. And that way, just in case this video gets seen by outside people, we just won't have, won't spill any personal information.
All right. Yeah, sounds good.
I have one more question for everybody. This has been exceptionally eye-opening and really wonderful. Does anybody have, because we would need everybody's buy-in, does anybody have any reservation to this getting posted either as a YouTube or publicly or used to do community education?
No, not at all from our side, I think.
Yeah, go for it.
Anybody
Great.
else on the
That's
call internally, just to get verbal buy-in? Does everybody else agree that's okay in order to share this publicly?
Maybe it's more of who doesn't agree to it, because I'm just going to take the silence as consent.
Silence is golden.
Mhm.
This is awesome. This has been amazing. Thank you guys so much for joining us and a wonderful education session.
Yes,
Oh,
really
yeah.
appreciate it. Thank you.
Thanks for having us. This was fantastic. I mean, I feel like, whenever, I don't know, I talk to people about MEV, either, they have like their mind all made up, and they like agree or they disagree, right? It's kind of like really black and white, I feel like, but like this was super nuanced and it's like really good questions. And like all of your concerns are totally valid, I think, as well, right? Like there's no real black and white.
No,
Yeah.
it's a muddy thing. And to be fair, the Lodestar team in particular, but ChainSafe also, like actually, I shouldn't even differentiate. ChainSafe as an organization is just very, it's some of the most deeply caring and just wonderful people in the space that, it's very proud to have you guys join us here because I know we all care deeply. I know it. We talk about it all the time. It's wonderful to, it's great. It really has been great.
Yeah, I can really tell how much you care, and I think we should. I mean, I would love it if we could find a way to work together, on something in the future. That would be really cool.
For sure.
Yeah, Matthew,
We'll
I
definitely-
love the passion. I love the hatred of block builders, and I mean that's how we go ahead and find the right way to do it, right? So
I'm just the talker, but I tell you what, everybody on the team, I know Nico is really passionate as well. We talk about it a lot. Cayman as well. I know Phil. It's definitely a team effort. I'm just a talker. It's really what it is.
Yeah, the great thing about this team is we generally have pretty various like perspectives on different things, which actually helps us with consensus within the team pretty easily in a way. Like we just throw ideas around. Everybody has different opinions on the way we should be building this protocol. So with your help and knowledge, hopefully we can come to better decisions together. That's basically the goal of these things.
Awesome.
Thank you.
So,
Thank you, everyone.
Thank
All
you.
right. I'll send you guys the details for this call afterwards and the recordings. And yeah, we'll talk on Telegram. Thank you.
Let's do it. Bye-bye.
yeah.
Yeah, thanks
Thanks,
everyone.
guys.
Have a
Thank you,
nice week.
everyone.
See ya.